So, so what we have discussed up till now is that in a series circuit, current only has one path to flow. Even if there are three lamps, it just flows through all of them in one path. But if we connect the lamps like this, where they are multiple paths for current will split up, then that's a parallel circuit. The second thing to remember about series circuits is because current just has one path to flow, in a series circuit, current is same. Current is same through each bulb or like through each component in a series circuit. Now, when I say component, I mean like it could be a bulb, it could be a resistor, it could be an ammeter, anything. Like it would be the same. But in a parallel circuit, current is not the same because in different components there's different current flowing. The next point about series and parallel circuits is for voltage it is the opposite because voltage is the energy given to a lamp, right? Sorry, voltage is the energy given to a charge to make it flow through a circuit. So when this current goes here, there would be some voltage given to the charges to move through this lamp, which would be V1. Some voltage would be given to this lamp, which would be V2, and some would be given to this lamp, which would be V3. So all of them, they would get separate voltage. While these three lamps over here, they all get the same voltage, which would be V. Because they are connected to the same points with the battery. Like these are common points, common connections. So we can say that in series circuits, voltage is different in each
Like,
component. Voltage is like it's neither electricity nor energy. Instead, voltage is the amount of energy given to a charge. Okay. Now, I know that I'm saying the amount of energy given to a charge, but you can't say it's energy because voltage is energy over charge. See, let's say I have got a charge here, okay, and I want to move it like all the way from here to here. Now, if I want it to move like that, I have to give it energy, right? So the energy that I give to this charge only is called voltage. So if you have a 7 volts battery, it would give 7 joules of energy to a 1 coulomb charge. If you have like 12 volts battery, it would give 12 joules of energy to a 1 coulomb charge. Like it would give more energy like that. Is that clear? So when you connect components in series, the battery gives different energy to charges to move through those components. Um, because they're connected at different points. Because voltage is always measured between 2 points. So these lamps over here, they are connected between different points. Like these points, they're different. While over here, you can see that it's the same point throughout with the battery. That's why it's the same voltage. So voltage is different in each component in series circuit. Now, occasionally it can be same, like, sometimes there can be a special case where it can be same, but mostly it would be different. The next thing is that, voltage in a parallel circuit is the same. Get through each component is same. So that's about voltage. Now coming back to that question you asked, like, how what happens if we like one of the bulbs stops working or something. So in a series circuit, if like I have these three bulbs connected and bulb 3 stops working, this bulb doesn't work anymore, then this means that the circuit is broken. Like this bulb doesn't work means it won't let current flow through it. So if current won't flow through it, all the other bulbs won't light up, because for current to flow, you need a closed path. So if current started flowing from here, it went through bulb 1, then bulb 2, and then when it reached here, there was no path, it would not flow at all. Current only flows in a closed circuit. But if you look at this parallel circuit here, um, if let's say bulb 1 stopped working here, then this 2 amps current would not flow, but the rest of the circuit would still work. Like there would be 8 amps current, 10 amps current here, then there would be current here, here. The rest of the two bulbs would light up. So in a series circuit, if one component like fails, or if you open the switch, the entire circuit shuts down. But in a parallel circuit, only one component will shut down. So if one lamp stops working, no other lamp would work, because of what? Because no current would flow through the circuit. But if you talk about a parallel circuit, if one lamp stops working, the other lamps will still work. Is this point clear?
Yes.
So yeah, this is like Bell series and parallel circuits. One last point, two last points we are left with. One is about switches. So we'll talk about how we put a switch in a series circuit. So let's say this is a series circuit with two lamps. And I put a switch here. A switch is like a button, okay? So if you open it, like the way it's right now, it looks like now, it's an open switch. So the circuit is broken, no current flows through the circuit. The circuit is broken, no current flows through it. But if I make it like this, then it's closed. Closed means that there is current flowing through the circuit. So when a switch is closed, current flows. But when a switch is open, like I'll draw it here. So when a switch is open, no current flows. So in a series circuit, if I want to control current in the circuit, I will just open the switch. Like if I want current to stop, I'll just open the switch. So both the lamps will stop shining. Here, both the lamps, they were working, while over here, none of the lamps work. So like I can't control individual lamps here. But in a parallel circuit, I can control individual lamps. So if I made the same circuit in parallel, it would look like this. I could like put lamps, put switches over here. So, and now you can see that the first switch, S1, is closed and S2 is open. So current will go over here. It will flow over here, split into some current I1. But it won't go above. So it will just split. It won't split up. It will just go through this lamp 1. While lamp 2 won't light up, but lamp 1 will work. Similarly, I can also open S1 and both the lamps will stop shining. Is this point clear?
Yes.
Okay. Right. Let's talk about the last point, which is where do we use parallel circuits and where we use series circuits. So in our houses, the electricity, do you think it's connected in parallel or is it connected in series?
Series.
Okay, if it's connected in series, so that would mean if you turn off one light in your house or like one light in your room, all the other lights would turn off. Does that happen?
No.
No, it doesn't. If they were in series, if the fan and the light, they were connected in series, then both of them would go off. Like if I connected all the lights and all like appliances, everything in my house in series, what would happen when I turn off the air conditioner, everything would go off. If I turned one light off, all the other lights, all the other fans, everything that would go off.
Mm-hmm.
So electricity in our houses is parallel. Is this point clear?
Yes.
And an example of series circuits is like, Christmas lights, they are connected in series because all of those lights, uh, if one of those small lights, it like goes off or is faulty, all the lights stop working. So Christmas lights or like decoration lights, they are an example of series circuits. So this is all about series and parallel circuits.
Yeah. Let
Like let's say
like
there are two bulbs in your room. You turn one bulb off. Does the other bulb go off too?
yeah.